Righto, if I can have your attention again for a sec. So we'll jump out here. I'll let Bill Grant take control of proceedings, so he'll lead you into our little soil pit. We're pretty happy with our wheat crops, so please walk on the spray tracks and don't knock anything down, you don't have to. The trial applications are the same at the last site, but they head right across, so again, if you can look out visually, there's not much to see difference in the crop, but Bill will talk on that. Our two rippers are here for you to have a look at. The 9-tine we've built and modified. My two sons up the back there, they operate it and help make it work, and sometimes get frustrated with me from my weird ass ideas, but so anyone who wants to have a look at those, more than welcome. The 2-tine was what got us started. It was imported by a mob called Compost from brought in from South Africa, which gave us the real simplicity of just dropping the compost in, as opposed to some machines that were millions of dollars to blow it in and do everything else. So, and we use that in vineyards and that to rip between the rows and the likes. There's rows of compost up here. They are out of one of the facilities in Melbourne called Sahir. Michael Woods is here. It's sitting there cooking away. That's enough from me, so I'll get out and have a walk around, and we'll try and get back on the bus about 12:30, thereabouts, to be back in for lunch at 1.
If people want to come in and have a look at the unit here, it's worth having a look. And I've got a video later can show you in action. But just come in and have a look. You'll see Frank's done some good work developing this unit. The compost that we're using flows really well, and really they're just modified rippers with a plate behind that slots the compost in behind. So you end up with a tube of compost in the soil down at the level you're putting it. Here we've placed it at around 25 centimetres down. And we'll go to the pit in a moment and you'll be able to see the ameliorant there. The soil here is, on the soil maps, it's the soil maps here classified as a sodic Subsoil soil, and it is duplex in terms that there's quite a difference between the upper soil and the subsoil. It's not incredibly sodic, it's a bit sodic, a bit dispersive, so the soil, the subsoil doesn't have great structure. The surface soil here is very heavy too, very hard setting. That's more to do with high magnesium to calcium ratios. You'll see it sets very hard, and the dry couple of months we've had. So this season, following the good seasons we've had, this season was shaping up pretty well. We got big dumpings of rain up till the end of June, and it's pretty much stopped there. We've had, up till a few weeks ago, we were getting a couple of mils a week, so it was sort of keeping things going, but we're slightly below half the seasonal rainfall we've had over the last 3 months. We're down about half the rainfall we'd have, and you'll see the effect. The crops though are probably, looking at this stage, the best you'll ever see. The last couple of years have put a lot of soil moisture down the profile, and the plants are, even in the areas that haven't been ripped and treated, the roots are getting down there. But if we get the dry finish to the season that we seem to be moving into, I expect we'll start seeing some difference. Maybe if we walk towards the pit, if people had a look at this as much as they want to, or have any questions for Frank about it. So the history of this paddock is that it's been close to continuously cropped for, about 10 years or so, and up till 2 years ago it was certified organic, so it probably got more tillage than the more conventionally managed paddocks. The soil's been bashed around, and it's sort of soil that you probably don't want to bash around too much, and particularly with the wet year last year, I think we got a fair bit of compaction happening. Declan wants to weigh in any time he can, but I'll try to show what we're seeing with the ameliorant here. Things have dried out a bit, so I should have brought my water bottle. So you see, cheers. I'll just wet it up a bit. So you can see the darker area here. So we haven't, here we've gone in sort of 25 centimetre. This is a 10 tonne per hectare, and they're pretty much, the spacing of the rips are pretty much that the alternative rows are on it. So that one's on, yeah, oh, in fact here you can see it more apparently there. People seeing that? Yeah. And what we're finding is the roots are getting down into it more and getting more vigorous root growth, which is what we're trying to achieve. The whole idea of this is, you know, we're trying to access moisture and nutrient further down the profile. And look, you wouldn't, yesterday when dug it, you can see soil moisture in this area. We're not into that. You can see quite a change there in the soil type, but we'd have to go down much deeper there. Further up the hill, that layer is up higher and we are into it. Yeah, but this is a very, very hard setting soil. You see how blocky it is. It's potentially very nice soil, but you know, we need to build organic matter in it for it to become a nice soil, I think, and deal with other constraints that are in the soil. This soil is a little unusual for the district. Most soils I'm dealing with that are acidic. This soil is fairly neutral in the upper layer, and then quite strongly alkaline in the lower. Certainly in this area, I tested yesterday with just the field kit, and I was getting sort of 8.5, 9 in that section, which is really not typical. Most of the soils here tend to acidic. So I don't know, Declan, do you want to weigh in on that one?
Well, the things that drive pH are the cations. So if you've got elevated magnesium or sodium in the subsoil, that's going to push your pH up. So the fact that if we are seeing elevated pH as we go down, it's telling us that we have greater cation imbalance as we go further down in the soil. So that is higher magnesium and sodium, and higher magnesium and sodium detract from soil structure. So when all this land was converted to agriculture, and we got rid of, the large plants and trees and everything that were here, we got rid of the big roots that had been living down in that deeper part of the soil profile forever. And when we got rid of those roots and replaced them with shallow rooted plants, and often for just half the year, the structure in those lower layers just collapsed. And so we lost the core network that facilitates drainage and oxygen movement to depth. And so what we're trying to do with subsoil amelioration is by putting organic matter at the impeding layer, so where we run into where conditions really start to deteriorate, we're trying to re-aggregate that soil, and then through the action of the roots moving through that organic amendment, they push further into those hostile layers, and in so doing, as Bill was saying, access deeper water, so that we have a bit more insurance if we are running into a dry finish.
Yeah. The other thing that's, the stubble retention and reduced tillage has been good for protecting soil and building organic matter on the upper layer, but there's a fair bit of work coming out now that's getting slightly better, but further down in a lot of situations, the organic matter is actually getting depleted because it's not getting, previously with tillage, it used to get integrated into the soil a bit more. So this is a way of helping the plant roots get down there, because less organic matter, some of these problems with structure, it's going to become more and more compacted, and you sort of get this vicious cycle going of it's more compacted, so the roots can't get in, so more organic matter can't get down there, so it becomes more depleted in organic matter. So this is really trying to encourage the natural system that the roots get in there, they feed well, they die, they feed soil biology, and you start getting that organic layer. And in theory, this is what we hope to see over the trial, is that effect will mean that you get a longer effect from your ripping. And what we found on this side, interestingly, is where we've done rip only, I'm seeing no difference between that and the control. And I think that's to do with the very wet year and the fact that it is quite a hard setting. If you look at some of these clumps here, these are stuff coming from the surface, and you know, it's solid, and it's really classic magnesic sort of soil that you get a real shine on it. Even that's got a bit of a, if you have a look at it when you break it, it's, you know, almost a bit of a sheen on it. So it's a heavy soil. You know.
Is this called Wallinger clay or Jaeger clay?
I don't know. I don't know. Yep.
Yeah.
Elmore gold.
Elmore gold.
No, we're not quite on the Elmore gold here, Andrew.
Yeah.
Just got a question for Declan.
Yep.
Would there be any value in adding, say, EM to the compost to try and get more facultative anaerobes in at that level to try and help assist that process?
I would say if it's a well-made compost, probably not really. So
Yep.
Tony's question was whether it would be advantageous to add the EM, which are effective microbes, which is, you know, bugs you can buy in a bottle, which have some pedigree, whether there'd be any advantage to adding those to the compost. And if the compost is well made, it's going to have really all the biological profile that it needs and can support, so probably not.
Yeah. The other thing, and probably a key message with why we're using a matured compost, is really it's a concentrate of longer lasting organic material. So there's been amelioration work done, the Department of Ag's doing quite a bit of work where they're using crop residues, fairly fresh poultry shed manure, that sort of thing, and they put it down the rip line. It tends to biodegrade pretty rapidly because it's got a lot of labile carb in it, which is great for feeding soil biology, but it means that you don't have a lasting effect beyond a couple of years. Whereas here we're putting in these tubes of pretty much potty mix, if you get in there. And the idea is that will persist for years and allow the roots to get in and start conditioning the roots, conditioning the soil around the pot of soil that we put in there.
Well, it almost makes it like a halo,
Right?
doesn't it? When you see the subsoil mineral that's been in there a long time, it's almost like a halo around that tube.
You see the effect, yeah. And Frank's got a paddock out the front here that I think it's been in the ground for 4 years now. And when we 2 years ago, when we were sort of assessing these paddocks, we put the corer in there and got it, and it really looked like the day it had gone in terms of it was still there. And I've got a photo that I'll present later on, and you can really see there the roots down in this soil that was quite hostile. We've seen the soil here after the last, particularly last season with rainfall. We've probably seen this soil the best it's been for a while, but you can really see the benefit. The other thing I noticed at sort of after we cut hay last year, I came out when things were drying off and did digging and found that there was soil moisture. After all the rain we had, there was soil moisture, but these clays can really hold on to it, so they don't always make that plant available. But in the ameliorant, you could pull it out and you could wring water out of it, so there was water in there. And whether that was an osmotic effect, that it was drawing it from the clay, or just the fact that we had a little pot of potty mix inside the clay, I don't know, but sort of thing we hope to find out through this trial. Hopefully we get some decent rain between now and harvest with things coming into flower, but if we don't, it will be interesting to see in coming weeks whether we start seeing a difference between the plants that are above the ameliorant and the ones that aren't, and certainly between the areas that aren't treated. So along here we have, similar to at Joe and Jess's place, we've got different rates. We're on 10 tonnes per hectare of compost here, and then we've got the different treatments with control areas with no treatment in between, and we've got some RIP only treatments. So we'll be coming in and collecting after harvest, coming in and collecting data and just looking at soil characteristics and how they've changed, and then subject to funding and support to look at what happens over the coming years, because this is it's an investment. It extends your RIP. As I say, last year you possibly only got 1 year out of your RIP. Most years you might only get 2 or 3 years out of your RIP. I'm thinking we might get 5-10 years out of using this matured compost, and that's what we're hoping to see here.
Any other questions to Bill or Declan or any of the composters in the group?
When you redo the next one, will you go in between the two, or will you go across it like a crosshatch?
No, you wouldn't crosshatch it. probably discussion would be you would split it. Yeah.
What is it, 457?
500.
500.
So anyone that's ever read Yeomans' Keyline book about how he did it when he designed that tine, or whatever you design with any of your rippers, just don't reinvent the wheel, just use the Yeoman tine, it works. And that's some of his work's based on that 550mm spacing, 500mm spacing, and you know, it's already all been done, so there's no point reinventing that part of the process.
And the other thing, you know, as I say, further up the hill, the ameliorant is more into this layer. Here we've got a bit deeper of the surface soil, but it could be that, you know, when you come back to do again, that things have conditioned enough that you can go a bit deeper. Yeah, so work your way down.
What
Okay.
sort of work, Declan, has been done with respect to these sort of sites with the biological sort of life in the soil? Have you looked at anything? I'm sure people are looking at it, but to my idea as an observer over the last 60 or so years, 70 years, we've never seemed to have spent an awful lot of time asking ourselves the sort of questions about what's going on here. And when you look at the regenerational sort of push that's on at the moment, and there's a lot of people thinking and talking about it, and I've seen you at a number of those, what sort of little gems have you got to tell us? Well, you're in the food business, and we're feeding crops, and we're feeding new bacteria, and we want to feed ourselves. So it's a nice circle of feeding each other. So are we closing any loops here? Is there a virtuous cycle going on?
Well, I think we're probably beginning to close the loop, because we're beginning to remember that the soil needs to be fed as well.
Yeah.
And the secret, you know, the secret of all of this is organic matter. And the reason why you know, we're running into the problems that we are running into is because we're not giving the soil enough organic matter. We're not putting enough organic matter back into the soil. So there's a lot of interest in soil health, but soil health, you know, it's not the sand and silt and clay that's healthy. It's what lives in it that's healthy, because only something living can have health.
Yeah.
So if we want our soil to be healthy, we want to have a big, diverse population of soil microbiology, and the only way we're going to do that is if we have a lot of food and energy in the system to support those big populations that we need to do all the work that we're asking them to do. So when we put organic matter into the soil, and as Bill was saying, increasingly we've got to think about customizing the input into this soil. So, you know, this soil, if it's got a lot of sodium or magnesium, might need a lot of calcium to go in with the compost. That is priming the system for biological activity. And then, as Frank was saying, the first crop to go in after a treatment has got to be a big rooted crop to scaffold all the fracturing that we've managed with the ripping. And what we're trying to do is push organic matter either through compost or root development into you know, a much larger area of soil to kick-start off that work that the soil biology do. It's all about getting organic matter back into the soil and more of it, which is why I'm expecting when things dry out a little bit more in the last property that we had a look at, we are going to see really significant differences from the high application rate and duration.
Yeah. And the other thing that's becoming very apparent is, you know, nutrient availability is, you know, a lot of it's to do with turnover by biology, and unless you're pouring on, you know, plant available chemical fertilisers and often through the growing season, this is the stuff that's going to keep providing that nutrition. Yeah, so I think there is a lot of interest. I mean, one thing I've really noticed, and I haven't seen a lot of work looking at it, the charts that are, you know, show the availability of nutrients at different pHs. if you look at the tolerance of a lot of soil biology, they sort of cut out at those acid and alkaline ends of the scale, that things become less available, and I'm sure that's not a coincidence.
Yeah, that's for sure.
If there's any other questions?
Do you have many worms in this country here, Frank?
Oh, thereby lies a bit of a story. So the other farm we were just on, Danny's the main operator, the Matt's cousin. Our boys do a lot of work with. I've known Danny's the same age as me. We drink a fair bit of beer together, and he's a good lad. He, as you've seen or heard, high input, everything else but direct drill. We did a field day for the very first time we set that up, and that big wheat crop on the hill there, everyone else was cutting hay because the crops were too dry, and it was muddy wet. And all he does, controls his summer weeds, stubble retention, high yielding crops, blah, blah, blah. Boys would come home and say, Dad, out at Danny's, dig up a shovel, worms everywhere. Come out here, we were organic, 5 or 6 tonnes of compost every year, no fertiliser, no chemical, nothing so-called bad for 5 or 6 years. The only thing we were doing was working the paddocks for weed control with a multi-disc. Not a worm to be seen.
Most worms don't like tillage.
So
It's a myth that
they
if
don't.
you chop them in half, they crawl off and form two new. They die.
So on that pretense, and we weren't growing crops, the weeds were getting out of control. So and the premiums weren't good enough, so we made the decision to go back to the nutrient method, but adding with the compost we've done. Not too bad a crop, the boys have done a good job. So still not many worms that we've found, but they're on the way back now that we're taking away that lump of steel hitting them in the back of the head. And they like Roundup. Bill and Declan have done a lot of work on worms from Tasmania to here, and yeah, they're interesting critters, and yeah, basically there's not too much worries them other than cultivation.